Good morning. So before we move on to what's the last major topic of the course, which is writing our own classes, we are going to go back to the lab. We do one last example on recursion. This week's lab is on recursion. Probably good to do one that I would consider a little more challenging, but hopefully when we start thinking about it and then we see how it works, and then this will help you week's lab. One of the things also I'm hoping you get from this is like the more examples you see and do, that when you see things on lab or quiz or final exam, you're like, oh, this is just like, such and such example, and then patterns. The example we're going to do move negatives example where we have a list of numbers and we want to create a list that has only the positive or the non-negative number in there. Before I do that, though, I do want to talk about one kind of Python thing. So I'll put that back in a second. But I do want to talk about one Python thing that we're going to use in this example that you will also want to use in Lab. So if we run the Python interpreter, so just run Python 3, recall that we can do concatenation with strings. So if I have a variable w1 is cat, and I have a variable w2 is dog, then I can say like word equals w1 plus w2. I think we saw this like the second day of class or something. Maybe not quite like this, but we have two strings, w1 and w2, and then I add them together, and then now word is cat dog. So this you already know, you've been doing an hour or so. It turns out we can do this with lists, which we have not seen before. So let's say I have nums equals 2, 0, 3. You do know how to add something to this list, right? We know that we can say nums append 5. So that you know how to do. But it turns out we can concatenate two lists also. So if I say something like, I don't know, LST equals nums, which is a list, plus, and then this other list, so this is new, we have not done this before. Nums, the list, this bracket 87 is a list. I can add two lists together, same way that I can add two strings together, and this will concatenate the two lists. So we're going to have as well. This.
Remind us the slicing.
Yeah, the slicing is kind of going the other direction, where we're removing, not so much removing something, but rather creating a list from a list with some stuff. So in this case, if I said list 1 colon, hit enter. So what this will do is create a list starting with this one, 0, 3, 5, 8, 7. That's starting at element number 1 and then going all the way to 2. And so essentially slicing off the first element. The variable LST has not changed, but rather what this did, this command here, list bracket 1 colon, created a new list starting from that variable with, you think of it as one element sliced off, but really starting at. If I put a number after the colon, it would tell us where. But we are going to, I'm glad you asked about that, because we are going to need to do this in this example in a second anyway. What other questions do you have?
Would there be a way to second list and add each?
Yeah, so this I'll repeat the question or I'll rephrase it. Like this thing here, list equals nums plus 8, 7, like kind of feels like I want to add the 2 to the 0 to the 7 and so on. But but the semantics of that is that it ends up. I don't know that there's a way to pairwise, if you will, without like writing a loop to do that. No one asked this, but let's say I have like m equals 4, 5. Remember how you can multiply a string times a number? You can do that with a list also. So, uh, 5, I multiply it times 3. Not on anything, but yeah, so we can chop things off the end of the list. We can use the list slicing, and the number after the colon, I think, is like the index where to stop, or it's like one pass. So we could, and therefore we could, just pop stuff up. Okay. So after you've run update 21, and then we go to our class week 11, and then we want to code remove negatives. This one is slightly different from previous ones in that this is slightly different from previous ones in that our previous examples were like kind of doing an accumulator pattern sort of thing. We were adding up numbers, we saw the lists, or we were counting something like counting the number of negatives. That's the one we did on Friday after the quiz. That was the counting of letters, but you get the idea. But here we're not returning an integer, and we're not printing something out. We're returning a list. So here we have this list, which I've also written on the board, and we've got this function I remove negatives I for iterative. If we look down here, we start. So this is the I for iterative, not the first person pronoun. And we start with an empty list, and then we iterate over the list. And if the number is non-negative, then we add it, we append it to the list. And again, this is something you probably would have done if I asked you to do this. But we want to do this recursively. And want to create a list that starts with this one that has the negative numbers. So we're, in this case, what we want is for this to produce 3, 0, which is not negative 12. So here's how we're going to approach this. We always want to approach it by thinking about the base case and the recursive case. But if you're a different color marker on the back, like a red one or just green. So you may notice, like a lot of these examples, it's like do something with the first element and then recursively do it with the rest of the elements. And that's the intuition here too. Where I start with this, I'll do something with the first element and then recursively do it with the rest of the elements, rest of the list. So if I want to remove, or if I want to create a list containing only the non-negative numbers, if this is add it to the list that I return. Otherwise, if it's negative, don't include it. Rather than add to the list, so if that first number is not negative, then I'll include it in the list. Otherwise, I won't include it in the list. And then for so the list that's returned either does or does not include this negative number. or sorry, the list that's returned either does or does not include the first number, depending on if it's not negative. Then it's the rest of the, repeat for the rest of the list. Include only the non-negative numbers for the rest of the list. And this is actually pretty similar to the one where we're counting the number of occurrences of the letter. That was the example we did after the quiz on Friday, where it's like, if this is the letter we want, increment the counter or include it. If it's not the letter we want, ignore it, and then do the rest of it. So let's start with our base case. And again, I hope that you start to see as you're preparing, as you're doing this lab, as you're preparing for next week's quiz, that will include recursion, and you start to see similarities. So the base case is where we don't do any recursion. We just call the function, just have a return value under a certain case. And I would say this is where the list is empty. So if the list is empty, then a list with all the negative numbers removed would still just be an empty. So in the same way, like we had the example last Friday, whereas if it was a string, if the length of the string was 0, had the one with adding the up values, the sum, the elements in the list, the list sum. If the list was empty, then we return 0. So here, we're returning an empty list. So if the list is empty, it is tempting and I suppose reasonable on line 52 to return 0. But we're not counting. Now we're not counting. In fact, we look at line 47, 46, 7, this function is supposed to return a list. So line 52 is empty, returning an empty list. So another sort of tidbit to keep in mind is think about what is the return type. Right? This says it's a list. 0 is not a list. So we want to return an empty list. There are, in a sense, 2 recursive cases. And again, this is really similar to the example we did on Friday. I know that was a long time ago. And life probably since then. But remember on Friday after the quiz, the recursive case was like, we look at the first element. And then we decide like whether or not we want to keep it in the result, or whether or not we're going to include it in the results. If it's non-negative, then we do want to include it in the list that it's returned. But if it's negative, then we don't. So let's do the easier case, which is where it's 0. First element is negative. If the first element is negative, then we don't want to include it in the list that is returned. Now you might be thinking, well, we never saw how to remove an element from a list. I believe that's true, but we don't need to, because we're not removing anything from the list. Rather, we're going to create a new list. But in the case where this thing is negative, we're just going to return, or say, okay, we're not going to include the negative 1, and we're just going to return the list that's formed positive number rest of them. So I'm going to recursively call, return R, remove negatives, the rest of the list. Actually, I'll put the comment above the statement. Doesn't matter, but. So remember, call it recursively. If you don't want to call it the same list, then it's just going to call recursively call forever. So what we're doing is slicing off that first element. Now we're going to find non-negative numbers from the rest of them. Starting with the negative. The last case, which is just an else, is where the first element is positive or 0. So when we get to the point where we have this 3, 0, 4, 12. So first time, call this function with that list that's there. The first element is -1, less than 0. So we call the function starting 2. Second time it calls the function. It's going to still go to line 54. First element is negative. It's going to go to 57. Starting with sliced off the first element of that list. Now we have 3, 0, negative 12, which is whatever. When we call this the third time, because this is positive, we do want to do this. So we want to keep the 3. And then, so we want to keep this and non-negative. So now that we have a list that starts with a positive number, we want to return a list consisting of that value. We want to return a list consisting of that value, then the non-negative numbers. So so don't say it out loud. I'm not asking for a volunteer, but see if you can finish line 61. And again, you could think about, I know it's been a couple of days, but you can think about the example we did on Friday, where we were getting the number of things. We've gotten to this case where we do want to include or incorporate value, first elements in our results. We want to return a list. That's the thing here. We want to return a list consisting of this positive value, then whatever find in the rest of the list. I'll give you a minute to let that sink in or think about how would you write that line. If it helps, we do need to include that first element. So I'll create a variable called first, and we do need to include that first element. Right, in this case, we want this. So a couple of hints. First of all of this is about recursion. Must have to call the function. So at the very least, you should know that in here we're going to call R negatives, and this function call here, this expression is this rest of finding the non-negative, however that works. And that was like we did in the example. Right. It's tempting to say, oh, okay, well, I want to include the first element. It's tempting to say I want to include the first element, then also the rest of the list. It's tempting to say I want first plus R negatives because I want that first element, I do want to keep it, and then whatever the rest of it. However, first is what type? Hence, this function is supposed to return a list. R negatives. We can't add ints and a list. However, like 7 minutes ago, I showed you something and I said we're going to need to do this. That's the list concatenation. So what I want is a list consisting of first. And then I concatenate with the rest of it. So what's happening, we get 3, 0, negative 12, that this is going to return list, 3 plus whatever. So it is kind of maybe strange that, but this where we put single elements, variable into a list, we create it. But what we're doing here is because we want to return a list, we don't want to return an integer. Create a list with that value, and then we're going to append it or concatenate it with whatever non-negative. So I did warn you a week ago that this was like the hardest topic in the class. And if this is not sinking in, that's fine. I hope what you'll do leading up to this week's lab is look at this example, look at the other examples in the week 11 directory. I think if you look in the week 11 directory, you'll see anything that ends with like Andy, that's Professor Dana, or Chris, that's Professor Danner and I have like put our solutions in there. We didn't talk about some of these examples. We didn't talk about the coordinated example, but so on. So as you're getting ready for lab, getting ready for quiz, please review those examples and hopefully start to see similarities between them. This I admit, confess, maybe it doesn't flow out of the brain. This doesn't necessarily flow out of the brain right away, especially if you've been thinking iteratively. But again, seeing these examples, I think, will help. What questions do you have about this? So in a minute, I'm going to erase this. But now we are going to move on to our next topic. And so, well, I'll do the slides first. And then. So the last major topic of the class is about kind of revisiting objects in classes. So I have 2 slides on this. So recall from earlier in the class, we talked about an object, which is a collection of data and functionality in a running program. And the class, the code that defines it. And an object is an instance of it. We, of course, saw string and list without realizing classes. Started to see point and circle with graphics. We had example, the student record, that's where we did an example in class where we read file and then created a list of objects, and then we did not, we did not see, why does it do this only when I'm teaching and not like, get there. We did not see country we saw earthquake. And in the lab that you finished or whenever, in all of those cases, like we as programmers were using those classes, we were creating objects or instances of those classes, but someone else defined them. Because someone else wrote the code that defines what a student record is, that decided that it had like a name. Someone else wrote the code that decided what an earthquake is. Someone wrote the code that defines what an earthquake is, that it has a magnitude and a full location, and so on. We have not seen how to write that code. We've seen how to use those objects, but we haven't seen how to create our own classes. So that's what we're going to do in starting today, and we're going to do a couple of examples over the next 2 weeks. So the example we're going to start with is to design an employee class, so, which might be part of some program that tracks employees, payroll, or something like that. I said that a class consists of data and functionality. And so we're going to say that in our employee class, employee consists of 3 pieces of data, which is the employee's name, their ID number, and their salary. So when I say that, you know, a class gathers this data together, that for one instance of this class, for one employee, they will have values for these 3 variables, and then a different employee will presumably have different values. So this is the data that's part of this class. In some cases, we call them fields. I'm also going to refer to them as instance variables because they're variables that go with an instance of this class. They're variables that belong to an instance of the class. A class combines data and functionality or with. And these are referred to as methods, which you've been seeing and using before, for instance, in lab 8 and 9. It's pretty typical when creating a class that you have methods that allow you to access the values variables, just like in the lab that you did last 2 weeks. Had a method that gets the magnitude. That method was called magnitude. That one location that was called get location. So the convention is to call them get, and they're typically referred to as getters, but you can also call them accessors because they're accessing those values. In our case, we'll say that an employee cannot change their ID. We'll say that we can change their salary. We'll say that in a minute, but we won't change their name. So we can say have a way of changing the name of the employee, and that would be a mutator because it's mutating the value, or a setter that is the convention is to call it set. And so we're going to see in a minute how we can create the getters and setters for an employee class. Now I mentioned that with an employee, their salary can change, and we'll say that we can only increase their salary. We can't decrease somebody's salary at our company. So we'll have a method called increase salary that is going to change the value of the salary instance variable, but I'm not going to set it to something directly. I'm just going to indicate how much I'm going to buy. Recall that all classes have a special function which allows us to create an instance of that class, and that function is called a constructor, which you have used. Student records, when we define the class, and you remember, I hope, that the name of the constructor is the same as the name of the class. That's earthquake. That's E equals. When we define this code, when we write this code, we need to call this underscore underscore init underscore underscore. So the constructor, which is the function that's called create an instance class, has a special name. So I'll just call it init, but it actually does have to have 2 underscores in front of it and after it. And then lastly, I might want to print an employee. And in the same way where you were printing earthquakes in the previous lab, asks earthquake print function and it magically knew how to print it. It's not really magic. There is a function called, name that function, rather, underscore str underscore. I'll just refer to as the str function method. So method belongs to a class function. But the str method, the string method, which we will be writing, dictates how does this thing get represented as a string. Before we start looking at code, I want us to look at the code and how we would use an employee at the same time. So I'm going to write this next part on the board. I'm going to leave it here while we look at the code, but it won't be in the recording, but then we'll actually come back and see. So in my code, I'm going to create employee. I'm going to be able to create an employee where I have a constructor, right, which is the name of the class, and I pass it some arguments. And I am, or we, are the ones creating the employee class, so we can say, like, the order of the arguments to the constructor can be whatever we want. We'll say that the first one is going to be string, which is their name. The second will be the ID, and then the salary will be a float. So later on, probably not today, but on Wednesday, we'll actually write code like this. But in this code, we're calling the constructor, which we are about to write. Well, and these are the units to the constructor, and this is going to be name, the ID. And again, in a couple minutes, we're going to see how we can write this code. When I want to print things, I can say something like name colon s. Well, if I have an employee object, how do I get its name? Well, it's not magic. I'm going to have a method called get name going to return the name. So this is a method that we are going to create that is going to give us the name, and that's why it gets printed. So this would be one of the. I can do this with the ID and the salary, as well. And it could be Mickey Mouse, it could be Minnie Mouse. I don't know. But anyway, it's a good employee. We're going to give that employee a raise. So I call e.increase salary, and because of inflation, we want to keep up with inflation. So or something like that. So early for inflation jokes. Don't worry, you have like 4 years of the economy ahead of you. Sure. So anyway, so we're gonna give Mr. or Mrs. Mouse a raise of 5,000. So now when I get the salary, say get salary. And then lastly, if I want to print the whole, I can just pass the whole object to the print function. And it's going to know how to print it nicely, because this will call or underscore s. In the same way that the constructor calls underscore init.
So even though when we make employee pass like salary, it's not still print.
Yeah, when we pass the ID and salaries like int and float, then if I call, for instance, like get salary, that is going to return it as a float. So that's why I'm going to here. Put the name. So yeah, we're kind of assuming that it's going to be the right type.
So like even though with the string method, like
this one here.
yeah.
Yeah, in this case, so there is a little bit of magic that happens here, whereas when I call print on the last line, I'll print e. That the print function knows all the str method, yes, which will return a string that, now I think I understand your question, that we will have to create that includes these non-string values, but we'll have to convert them to string,
Okay.
so that we can. So if if this had been a lab or whatever, and we gave you the definition of the employee class and said, here are its methods and so on, you would be able to do this. But you did it for earthquakes in the past 2 labs. But what we had not seen up until right now is like, what does the code look like that defines the employee class? So that's what we're going to look at, start looking at right now. So to do this, you'll need to go into your week 12 directory. Make sure everybody's in the week 12 directory. I know we only have a couple minutes left, but I do want to put a little bit of a dent into this example. So in the week 12 directory, you should see 3 files. We're going to look at this employee one. Employee test is code that, kind of like what's on the board here, that uses an employee object, doesn't define it. That's what is employee.py. And then flight is one we're going to do later in the week. So we'll do code employee.py. The first part is the hardest part, and then I'd like to think that once we get our heads around important concepts, then we'll be fine. I'm gonna erase, because I don't think we're gonna get to these other methods. I'm gonna erase all of it, but like 30 seconds or so, I'm gonna erase what's on. So here in the employee.py, the comment says, this is not really a program, but rather it's the definition of a class to represent an employee at an organization and includes their name, ID, and salary. And on line 6 is something we've not seen before. So line 6 is where we're starting the definition of the employee class. Employee. So we have the keyword class. That's we're defining the class. We're what an employee is, followed by the name. It's the convention that the name of the class starts with an uppercase letter. If you think about point, circle, student record, earthquake, those all start with uppercase letters. It doesn't have to, but it is. It's also the convention that it's a file. File is the same. That doesn't. But we do have the name class and followed by. The next thing is what appears to be defining a function. So the next thing appears to be defining a function on line 8 here. And it is. It's defining a function that's part of this class. So that's why it's indented to be beneath line 6, indented after line 6. And we're defining this function that's part of the class, and therefore this is a method. So a method is a function that's defined inside a class. And you can see the comment says this is the constructor, which is the function that's called when it is. The constructor has to have this name underscore in it. Even though here, when we call it, you don't see whatever black. You don't see underscore init underscore. We don't call it. We call the name of the class. Does two things. It creates an instance of that class, and then it calls the function. Explicitly. The constructor, as you see, takes 4 parameters. However, when I wrote this code here, I only gave it 3 arguments. The first parameter on line 8 is self, which leads to the existential question: what is self? What is self? Self is the object on which this method is called. You're going to hear me say the word self many, many, many times over the next 2 lectures. You're going to hear me make the same stupid joke about what is self a couple more times. Not laughing. But self is this object. In other programming languages, it's something called this, meaning this object. In Python, it's self. But it refers to the object on which the method is. See momentarily how it's used. The rest of the parameters, we should have no problem with being the name of the employee, except just IDs. Yes, ID number or salary. But the first parameter must be self. This doesn't return anything because the line of code that's on the board here, it creates the object, it calls the constructor, and then this process, I guess, is returning the object, calling E. Now we get into the body of the constructor, and note that we need to refer to the name instance. Note that we need to refer to the name instance of this object using the parameter self. Okay, so let's take a look at line 21. And if we understand what's happening with line 21, then I think we're good. So in this case, we want the employee to have an instance variable we want the employee to have an instance variable named you have to somehow associate that variable with the employee. You have to associate that variable w/means with the employee. So let's look at some options for how we can do that, and then we'll see why we need to do this. If I said something like name equals name, so don't type it because this is wrong. But if I said something like name equals name, well, that doesn't do anything. Name, that parameter there, and just setting that parameter to itself, which doesn't do that. So there's no, what I've written on line 21, which is wrong, does not associate the name variable with this object. You might say, oh, okay, well, I'll just give it a different, I'll call it a different thing. I'll change this one to like n, and I'll say name equals n. This is also wrong. At least they're different, but line 21 is just a variable in this function. It is not in any way associated with the employee object. I'm going to go back. So this on line 21 is correct. Name is the instance variable.
Self like
Say it again.
self be like that.
So when this thing kind of comes back, like E and self are the same thing. They're both refer in the stack diagram, which we're not going to do right now, but we will Wednesday. We would see that E and self are that, and so what we're doing is kind of associating this self.name says, okay, in this object we're going to have an instance variable called name, and we're setting it equal to the parameter name. I know it's confusing to have all these names, so if it helps, we can just call this like nm for name, nm here, and then this would be nm. So nm is the parameter that, in this case, would hold the string m mouse. The self.name, self is this object, and name is the variable that's part of the. So I'm going to stop there, and we'll pick this up on Wednesday. Just a couple, I know you got to go, but lab 10 is going to have two parts. The first part asks you to draw stack diagrams through recursion. You need to print that, write it out, bring it to class. Okay. The rest of it is code part. Okay. And then yesterday I wrote a unnecessarily long ed post about the stack diagram question and realized I did it wrong, so I rewrote the unnecessarily long stack diagram post. So please read it. It was like an hour of my Sunday. I think it's please read that.
I did. Professor, I was just wondering.